welcome to The Explainer. Today, we are going to hack innovation. We're going to dive into this incredible system for genius-level problem solving and build a toolkit you can start using, right away.
I'm sure you know the feeling, right? You're working on something, and you make it stronger, but then it gets heavier. Or you make it faster, but now it eats up way more energy. It's that classic, frustrating trade-off, and it's at the heart of so many challenges. You're just stuck. You're caught between a rock and a hard place.
So, what if I told you there's a key to unlock these impossible problems? Well, there is, and it's called TRIZ. It was developed by a Soviet engineer, Ginrich Altshuler, after he spent years analyzing millions of patents. And he made this stunning discovery. The same basic problems and the same solutions just keep showing up over and over again across totally different industries. It's basically a roadmap for invention.
All right, let's get into it. Here's what we've got on tap today. We're going to hack the whole inventive process by building a mental toolbox with 5 powerful and, honestly, kind of counterintuitive TRIZ principles that you can start using immediately. You see, the whole point of TRIZ is to solve what it calls engineering contradictions. Yeah, those annoying trade-offs we just talked about. But instead of just settling for some lame compromise, TRIZ is all about finding that breakthrough, that inventive solution where you actually get the best of both worlds, no trade-offs.
So, let's grab our first tool. And this one, it's all about using clever replacements. It makes you question whether you always need the real thing, especially if it's super expensive, hard to get, or maybe just too fragile.
Yep, this is Inventive Principle number 26.
So the big idea here, the question it forces you to ask is, can you solve your problem not with the actual object, but with some kind of copy of it? The answer can lead to some seriously elegant solutions. And you can see how powerful this is in the real world. I mean, it's brilliant. Instead of a super pricey vacation, you use a virtual reality copy. Instead of sending people out to survey dangerous land, you use an optical copy, a satellite photo. And get this, you can even copy stuff that's invisible to us, like using infrared to see heat and spot diseased crops from way up in the air.
Okay, let's grab the next tool from our kit. Now this one goes against everything we're taught about making things that are built to last. Sometimes, and this is a big one, the most inventive solution is actually the most temporary one.
Which brings us right to Inventive Principle 27. What's so cool here is the total shift in thinking. Instead of one expensive, super durable thing, you get the same result with a whole bunch of cheap, short-lived items. Just think about disposable coffee cups or, single-use medical gear. The goal isn't making it last forever, it's about getting the job done cheaply and effectively. All right, our third tool. This is where things start to feel like science fiction. It helps us get past clunky, physical, mechanical fixes and start using the invisible forces that are all around us. I mean, why bother with clunky gears and levers when you can just use invisible fields? And that's Inventive Principle 28, Mechanic Substitution. It's all about... Now, the really mind-blowing thing here is this core idea. Replace physical touching with interactions based on fields. This isn't a small step, you guys. This is a huge leap. It can simplify systems like you wouldn't believe, get rid of wear and tear, and just open up brand new possibilities. And you see this in some absolutely amazing applications. Instead of physically stirring 2 powders, you can charge one positive, one negative, and just let them mix themselves perfectly. Instead of blasting a signal out in all directions, you structure the field with a complex antenna. Or you can heat something from the inside out using a magnetic field. No flame, no direct heat, nothing. Okay, next up, we're actually going to look at 2 principles together because they share this really cool common theme, getting rid of rigid stuff and making things more adaptive. It's all about swapping out solid structures for things that can flow and bend and change their shape. So on the one hand, you have Principle 29, which says, hey, use gases and liquids instead of solids. Think about the gel in your shoe inserts or the hydraulic fluid in a giant excavator. And then on the other hand, you have Principle 30, which is all about using thin, flexible films instead of big, bulky structures. A perfect example is one of those giant inflatable domes they put over tennis courts in the winter. See? Both are about being less rigid and way more adaptable. So there you have it. In just a few minutes, we've added 5 really powerful, really concrete strategies to your problem-solving toolkit. These aren't just vague ideas. They're specific prompts to help you smash through those creative blocks. Let's do a super quick recap of the tools we've covered, okay? Remember, copying. Use a stand-in instead of the real thing.
Think about cheap objects, lots of inexpensive things instead of one expensive one. Substitute mechanics with fields, use invisible forces. And finally, use fluids or flexible shells instead of rigid, solid parts. Every single one of these is like a new pair of glasses for looking at your problem.
So we've given you the framework, right? A whole set of keys to unlock problems that probably seemed impossible before. Now the only question left is, which door are you going to open first? What's that big contradiction that you're finally ready to solve?